Hi, good morning, everyone. Welcome to our Virtual Research Academy talk and conference for today. This talk will be recorded. Let me wait until some of the people that are on the waiting room enter to our conference for today. Just 1 minute more, please.
Maria, we have students from Russia, from the Republic, from Chile, and from Nicaragua, and what else? From the Dominican Republic, and from Puerto Rico. Yeah, this is great. International.
International.
Yeah, this is an international conference. Yeah. yeah, actually, yeah, right.
Hi, welcome everyone to our Virtual Saturday Research Academy talks and conferences. I have still people waiting to enter to the conference, but we are gonna start. And let me show you our agenda for today. Please fill the participant survey and the evaluation of the conference. And I'm Dr. Elba Sepulveda, and you know that I am the evaluator, also the moderator of these activities. Please remember that we are collecting basic information about the participants. You can be a student, mentor, teachers, parents, or general guest. You can fill the survey. It is on the chat. And now we are collecting email. If you want not to give your own email and put another, is okay, because we are not sending any information to you, and we are not providing any personal information in my report. But we need to have some information about your feedback and where are you located. So it is nice to have that information, because that will help us having more activities like the one that we are having today. So I'm gonna leave Dr. Juana Ratia, who is our director, to give the welcome to the conference. Thank you so much for being here.
Yeah, thank you very much, Eva. Good morning to everybody, and good night to Maria, who is in Japan, really, Tokyo. So she is a Fulbright scholar. Yeah, she visited Puerto Rico and she liked it very much. And we have been collaborating with Maria for a long time. Actually, she has been working with some Puerto Rican students, okay, in her field, and they are ready just to publish information. So thank you very much, Maria, for being with us today. And we are really excited about to hear about your gamma ray burst in what is in the world today. Thank you. You can go.
Okay, thank you so much, Dr. Ratia, for your very nice presentation, and it is a pleasure for me to be today to give this brief overview of my research in collaboration with the Puerto Rico student of the Scientific Caribbean Foundation. So I'm gonna share the screen, and please let me know if you properly see. Okay, so I would like to tell you today about gamma ray burst, the most explosive phenomena in the universe. And this adventure started many years ago for me when I was a PhD student back in 2005. But then I started to investigate more and more the role of selection biases on gamma ray bursts. And then that's why I moved to Stanford University through my Fulbright scholarship. And it was at that time in 2012 that I was invited by Dr. Arratia during the Fulbright Visiting Lecture. And since that time, more than 10 years now, we have been in contact, working together to help and mentor students from the Scientific Caribbean Foundation. Now, what are gamma ray bursts? Gamma ray bursts are explosions of massive stars that can come either from the explosion, in fact, of a massive star, or the merging of two neutron stars, the coalescence of two neutron stars. But the point is that I would like to tell you also how I usually catch the attention and the interest of the young students, saying, to the general audience what this phenomenon is about, and telling that these are the one of the most farthest objects ever observed. The one it is the one that it is observed at the greatest distance. It is observed at redshift 9.4, which means 13.14 billions of light years. So it is very close to the edge of the birth of the universe. And now I would like to present some features of the gamma ray burst. So this is a light curve. Light curve means that you have the photons that are coming from the detector on Earth. So we have three phases of the gamma ray burst. The prompt emission, when these high energy flashes are emitted, the decay phase of the prompt emission, then the plateau emission, which is the flat part of this event, and then the afterglow emission, which is the counterpart in optical. So here, this light curve is also one of the good light curve that it is considered the gold sample. Now, this light curve has been observed by the Swift telescope, which has been launched in 2004, and it is a satellite whose observations are still ongoing. The blue line is the phenomenological model of Willingham. And I would like to tell you a little bit more about that, because together with the student from the Scientific Caribbean Foundation, we process this data in the sense that we perform the fitting of the Willingham function or the broken power law function in multiparametric space. And now I would like to tell you a little bit more how we tackle the research project. Usually I assign at the beginning easy tasks, and then the task will be getting more complex, more complicated, so that the student can have a steep learning degree. Then I usually meet the students regularly, at least once a week, for 2 hours or 2 hours and a half, depending, on both availability on our side. And ideally, I realized that it is better to meet more frequent, but for a shorter time. And then, because the number of students was growing in the past year, and actually, I would like to tell you that this year I counted in total 42 students between undergraduate, graduate student, and high school students. So then it is from 2019 that I opened a Slack channel in which students are all connected with the mentor and senior and other students. So this Slack channel is very, 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 very useful. And of course, as in any community, you need to define rules for being part of the group, because this is an open sharing of the resources, so we should all be considerate on the data that we are using and the code that we are using and the policy that are behind this work. So, I want to share with you very happy news about when the paper has been submitted. You see, this is 21st Tuesday, 2021, so several months ago, we submitted this paper. And then, this is the Puerto Rico research group, and we will specify the commitment for NAOJ, and this is, the very happy day we are still working on. Now we got the referee back, and we are working on these results. So this is, I also want to show you that, this GRB light curve channel, it's one of the channel, and I have many channels here in this that represent several parts of the research. So for students that would like to join one of the research, they can come be part of one of the channel, and then if the research is growing in the sense that the student would like to join more bits of research, they can also join multiple channels. And to make the research easier, we are creating a GitHub repository. So the GitHub repository is free, and this is shared by all students, in this case and me. And so we share also piece of code with Mathematica. Now I would like to tell you how the research went ongoing. So we had the problem of extracting and wrangling all this data, and it was really very hard because we have many sources, and the students were so helpful to go through the huge amount of literature to store this data. Then we created this open source Python package for better data gathering, so that we didn't need to do manually at all time. And so we started with the search in literature and the circular notices. Now the students from Puerto Rico are very expert about how to get to the literature, gather the data. Then we worked on conversion, because one of the problems was that all the data were in different formats. Sometimes they have magnitude, sometimes in fluxes, in energy over erg over centimeter square per second, and in other cases were in Jansky or in millijansky, so we needed to convert in the same unit. Then we need to plot and cleaning the data, because some of the data were not maybe very well processed, so we needed to understand which one are good for the analysis. And then we proceeded with the light curve fitting. So basically you see that all the preliminary stages of this research was composed by 4 parts, and the Puerto Rico students were in literature gathering, in the plotting and the cleaning of the data, and the light curve fitting. This automatic conversion was done by me and another student from undergraduate from University of Pennsylvania University. Now I would like to show you some practical example how this circular notice are created and how they are looking like. So we have the number of the circular notice, and then we have the name of the GRV. So 20 means that it was exploded in 2020, 10 it is the month, and 20B is the date. So then this is then there is the name of the person that observed, and from where it was observed and which satellite. So with the student, we have now an ongoing part of research that it is to classify from which satellite we are observing the light curve. And once again, they were very helpful to divide, for example, the telescope, the Japanese contribution, the American contribution, and other contribution from other satellites, so that in the web page, which is the next step of our research, we are going to make all this effort publicly available. And now I would like to tell you a little bit more about this pipeline structure and the work in progress we have been doing to create a package for public use. So this package is not yet publicly available. We are working on it, and it will be publicly available after we have the publication accepted and fully published. So we have the circular notice from NASA. Then we parse the table and the sentences, so then we can have the extraction of the fluxes, and then we have the we parse the magnitude and fluxes, so that we can have the data table created. And now I would like to show you this web page interaction. So these are the points of the light curve. You see, this is a friendly interface, because you have in several colors the different bands of the light curve, and all the singular points have been collected by us. And I can tell you that we collected more than 20,000 points in all this year long of research. So of course, you see, some of the points were not really well processed, so we need to discard them. And you see, the rejected points are now highlighted in yellow. So this interactive page is going to show you this light curve, and you can manually accept or reject data points. So this is very useful for people that would like to repeat our analysis, or maybe they need the light curve to do a different analysis, so they can go to each of the light curve and work on that. Then we created this light curve fitter, so that you can quickly provide an initial guess of what should be the light fitting and what can be immediately returned. So this is the output that we see. And again, the Puerto Rico student also became pretty much specialized to do this multi-parametric fitting, at least in three parameter space. So I'm very proud of the progress that they made, in 1 year and a half. And here you can see how the code works. It imports the data, it imports the data points, and then you can accept or reject, convert directly in fluxes, you can accept or reject the point, and then you can try to attempt the fit. So now, as I told you that we gathered more than 20,000 points and plotted through our pipeline So we had 44 good light curve in addition to the previous 131 light curve. So I would like to mention that, that the students from Puerto Rico, they started to join this research in June of last year. So as I said, it's 1 year and a half this research is ongoing, and they have been mentioned in the previous publication in which they were helping with the data gathering, but in this paper there will be co-authors. So this is a huge important step for the student. And overall, we have 70% increase in the sample from Dianotti et al. 2020. We can have this on-the-fly conversion from the fitting flux to the luminosity, and then we can consider the 2D correlation comparison with the optical data and the X-ray data from a previous correlation that I discovered in previous years. As I said, the package will be released to the community, and we have a novel computation for the 3D correlation. So I would like to show you some of the faces of the student, and you can recognize that three of the students belong to the Puerto Rico Foundation. Other students joined a group also from Puerto Rico, and the student is from University of Pennsylvania. So this plot that shows the three-dimensional correlation, so luminosity at the peak in the prompt emission, luminosity at the end of the plateau emission, and time at the end of the plateau emission, this builds a three-dimensional correlation that identifies a plane. So this plane is very tight when we consider some categories that are called the gold sample, and you can see that in several different colors we indicate the different classes of GRB. Orange for the GRBs that are associated with supernovae, red the short GRB whose duration is less than 2 seconds, the blue are X-ray flashes and the X-ray rich, that means X-ray flashes that have more energy in X-ray than gamma ray, and then the regular long gamma ray bursts that they last more than 2 seconds. So now I would like to tell you a little bit more, and the meaning of this correlation is that the energy reservoir of this flat part is constant, and probably it is a magnetar event, so it has fast rotating neutron stars that produce these events. Now, one of the rules that I will ask to the student is to respect the commitment on both sides. So if you're unsure about the commitment, it's better to give a lower limit estimate, not to put in trouble your peer students and your supervisor. Of course, you want to be respectful of the deadline of the assignment. Inform your mentor of any problem you're getting ahead of time, being respectful of the time of the supervisor and other students, because sometimes, if you embark in a project and then you drop in the middle of the project, this can cause trouble not only to you, not only to the supervisor, but to the group of students. So then, usually what I recommend for this kind of project that are also lengthy one, that's good to commit at least for 6-8 hours per week. So it's kind of requirement for this internship. And then one of the policies that I built during the years, that you should be very respectful and trying to take this as a very good opportunity for you to learn. So you want to be sure that you want to do this commitment that can lead you to the publication. And then the internship is unpaid. So on both sides, it means that I'm not getting paid for the work that I do together with the student. It is like the NAOJ that allocated some of my time to work with you students. So you also need to be considerate about this voluntary basis on your side as well. So then I would like to tell you about the advantages, of course, of being part of this internship. So of course you will be part of an international team of scientists and students, because in the Slack channel there are also professors, and so you can meet with other young students of your age in other countries. The Slack channel is really connecting people from Italy, Poland, mainland US, Puerto Rico, India, Japan. And so you have the chance also to know different culture and learning how to work in group, because one of the point of being a Fulbrighter, and if you're a Fulbrighter once, you should stay Fulbrighter for all your life. So in being a Fulbrighter from Italy, I need to continue to be ambassador between the relationship between Italy and the US from a scientific point of view. And so this, I broaden up this message worldwide. So helping each other in an environment with a positive vibe, which allow you to learn with a very fast pace. And of course, the last goal is to publish in international peer review journal. And here, I would like to show you this publication. You see, there are the students from Puerto Rico that are listed here in the list of people that we submitted this paper. So now the reviewer comment. Besides all the technicality of the reviewer, they say the paper is worth publishing, and of course, we are working on it. So beside the following comment and invite the authors to address them before acceptance is recommended. So this is the review words. So now we are all excited because the adventure continues with this paper and with even additional work. So I want to tell the new students, if some students want to continue, I'm very happy to keep them on board. And I'm at the current stage, I became a PI of an effort of observing optical afterglow with the Tomo e Gonzen. It is the Kiso Observatory in Nagano in Japan, and this is it's a 1.04 meter telescope, and we started the observation recently. So we have observed already 4 GRBs, and we are in the moment of processing them. So if you want to embark also in this more observational adventure, please let me know. So thank you so much for your attention, and you are invited to join us in this research. Thank you.
Well, thank you very much, Maria, for all that introduction to your program, and also the opportunity that the students have, you see, to get into this very interesting area of research. So it's a very challenging because you are going to learn a lot of stuff, but maybe you never saw that exist in terms of tool, in terms of opportunities, in terms of projections. So I really enjoy that. But let's put this presentation forward with the question from the student and from the faculty that is around here. Okay. Any questions? Elba, do you have any comment at the?
Yes, sure. I would say thanks so much for your participation and for getting, this information. I think that this experience will be a great addition for any of our students. I want to know a little bit about what are you looking on the applications? What do you think are the educational experiences, or what things are you looking for in those people that are applying to your internships?
Yes. Thank you so much for your question. Yeah, actually, the educational experience would like to. I mean, the aim in the end. I think I mentioned in one of the first slides that I would like for the student to get a steep degree of learning. So basically, the student, after the first introductory part in which I explain what gamma ray bursts are, I would like the student to be directly on board in this adventure of the research. So this is my goal, to get them involved at the early stage. And I remember many students told me that the nice things that they like about this internship, that they can get directly to the point of how you do research. So if students are astronomy interested, then they can know already what will entail to pursue a research career already from the early stage. So this is one of my goals for the educational part of the student, and of course the learning of what are gamma ray bursts, their energy emission mechanism, and some more technical knowledge about the Python or Mathematica code. So plus another point that I would like to foster in this kind of mentorship and internship program is the teaching the student how it is nice to collaborate all together with other students, with the senior member, PhD, postdoc, and professors. So that it is like the takeaway of this experience. So I would like them to learn how to interact each other also.
Yes, from what you are saying, I just get to know that they don't need to know a lot of astronomy, or they don't need to have a deep understanding of deep things, because that will be part of the research that they will be doing. As also that they will need to be interested in this particular, topic, and be able, to collaborate using all the channels, using Slack. But do they need to
Yes.
know some math, or they will need to study
Yes.
something?
Yes.
Mhm.
Yes, so the according to I try to how to say customize the bit of the task of the research according to the initial step, initial how to say knowledge of the student. So thank you for your question, because this is very important. Three of the Puerto Rico students that they started that they didn't know how to use a Mathematica file. So they only knew how to use Excel. So we started with Excel, and I told them, be patient, for this time being, you will participate as acknowledged, will be acknowledged in the paper, but the next stage, step by step, you will learn more and more, and then you will be part of the next paper. So then they started to build their experience, as I said. So they started to, understand how the data were processed. So of course, if the student have knowledge of Python, for example, like some programming languages, Python language or mathematical language, or any other coding experience, this is very, very helpful for joining this part of research. But I also spend quite some time, if the students are not at the level yet of coding. Sometimes I sit together with them and I show how I do. So then they can learn step by step. Then I share with them the data, the code, and then they can do by themselves at home in their own time. And this is the learning process. So
Thank you. Thank you so much. Thank you. We have not only students from Puerto Rico, but we have right now students from Russia, from Nicaragua, or other places around the world. Do they can apply to this program in the same way that U.S. citizens or your people there can apply to it?
Yes, yes. My program is open to any student from any nationality. So I like the international group. That's one of my goal is to feel in the global village of the world. So many comments that I got from students from US and from Puerto Rico and also from other countries, that they were so excited because they could meet same age of people but completely opposite in the other side of the world. So yes, they can apply in the same way.
Maria, there is a question from Adrian Escalera, and says if there is a deadline for the application.
No, there
So
is
it's
no
open.
deadline. No, there is no deadline for application. Is it open at any time? And according to the project that I have at that moment, I can, after speaking with the student and knowing what the student's level of knowledge of astronomy or math or coding, then we can decide which project the student can embark. I usually have a 1 month of onboarding. So it means that in this 1 month, the student can feel whether or not would like to engage seriously in the project, more seriously in the project. So this month I did that so that it's both sides, both the student can know whether or not he or she feels he could participate to the project. And if after 1 month the student feels comfortable and the project is going, then I'm gonna to include the student in the Slack channel. So this is the recommend, because in a month you feel that the project is not for you, or you cannot commit time, then both ways it's good.
Yeah.
There is an
Yes. So
Elva,
yes. So I'm now reading the
Adiseta,
chat.
Diego.
Actually, I'm accepting any student from any level. But of course, the master or doctoral student, they can do more advanced research. So usually they can, be ahead in the authors list. So also the older students are very, very much welcome in my group. Yes.
do
Right.
they need to send you an email, or do they need to go to a website to apply? What are the
They need to.
steps? Mhm. I'm
Yes.
sorry,
So
you may say that before, but I just want to summarize the
yes,
ideas for.
thank you. Yes, the idea is that they would need to send me an email with their CV. So 1 page is enough, in which they list their interest and they list their previous knowledge or previous if they have done already other internship, what they worked on. So a little summary of what they did, and then I can usually set up a meeting with them in a time zone or in a time hour it's convenient for both of us, and then we can further discuss about how they can be involved in the project.
Thank you so much. Do anybody has any more questions?
No question.
Please, you can use your microphone or you can write it down on the chat.
In the
You're
chat.
welcome to do so.
Yes. Well, Elva, I think there is no other question. So maybe you can explain about the attendance, or yeah, right. To the attendance, exactly what they had to do in order for us to learn about their feedback. Okay?
Yes, and well, we were on the Q&A sessions, so I'm gonna show you that we can have the participant survey link. I sent that into your chat. Also, you can give us, I'm sorry, it is not Dr. Toruyagi, it's Dr.
Maria
Dianotti, okay?
Yes.
Let me fix it.
Dianotti.
Let me fix it. Okay, so then you have our sponsors here, that is this Citizen Diplomacy Action Fund and the Scientific Caribbean Foundation of Puerto Rico. Please fill out our survey, our evaluation survey. And I sent that to you on the chat. Our next presentation is going to be on January 29. I'm sorry. Yes, next
Saturday.
Next Saturday is February 5. I'm sorry, because I left the date wrong. And is about Norwegian University of Science and Technology in Norway, Fulbright visiting from that area. And he will be talking about color and image processing. So please feel free to go to our website and enroll yourself in that. And now I will put our verification of attendance. So you can take a screenshot and about this. And I would thanks also Dr. Maria Dianotti, that was very good explaining us all these information. And thank you so much for being here. I will let Dr. Aratia to say the final words that he always say before we go. Okay.
Okay, thank you to everybody. And I think there is a new way, you see, to spend your time by just learning about astronomical phenomena in the world. So Maria Dianotti, Dr. Maria Dianotti, she's a great mentor. I've been working with her for just a few years, more than 10 years. And I recommend her just for you to work with her, you see, during the period of time. You are going to learn a lot of mathematics, you see, computing kind of stuff, but also you are going to learn about astronomy. And that is very exciting field anyway. So I really appreciate and I thanks Maria Dianotti, Dr. Maria Dianotti, for being with us today.
Thank you so much.
She is always available in her email, so she will answer any question you might have. And so thank you very much, and have a good day. Even that the day is going to be over in Japan, but here we are just starting the day. All right.
Thank you so
Okay,
much.
for everybody. Yeah, for everybody. Yes, thank you very much for this to participate in this conference. All right, Maria.
Thank you so much.
See you next time. All right.
I'm gonna
Bye.
stop
Yes.
the recording now. Thank you so much for
Perfect.
being here.
Perfect. Excellent.